All right, today we're going to talk about vertex form, right? And so you guys have seen vertex form before, right? And you did a Desmos on it, and so we're just going to formalize it. Okay, so we're going to look at these three quadratic functions, which actually, although they look different, are describing the same exact function. Okay, and so this is what we would call standard form, right? For quadratics, this is going to be our factored form, right? If we factor it, this tells us where our solutions or our x-intercepts are, right? Our zeros. And this last form, which looks familiar, is vertex, okay? And vertex form tells us the vertex. And so let's find the vertex first using the methods we know and relate it to this final form. So, sorry about that. Okay, so I'm gonna use negative b over 2a to find my axis symmetry, right? So in this case, it's negative 12 over 6, which is negative 2. So at x equals negative 2, we have our axis of symmetry. To find the vertex, I'm going to plug in negative 2 to find the y value. 12 times negative 2 minus 15. This is going to give us 3 times 4, 12 minus 24 minus 15 equals negative 27. Okay, so my vertex is negative 2 comma negative 27. So we know that the axis of symmetry is here, and just so I can kind of sketch this, I'm going to scale my y-axis by 3, and we'll just scale x by 1. Okay, so negative 2, negative 27 is going to be right there, okay? And if we factored this quadratic, we would get this factored form, right? And from this factored form, we can easily solve for when y is equal to 0 using the zero product property, right? So we get x minus 1 equals 0, or x plus 5 is equal to 0. So we know that x is equal to 1 and x is equal to negative 5. And so we know that this parabola is going to have a x-intercept at 1 and an x-intercept at negative 5. And is going to open upward, and so just kind of sketch this out. It might look something like this, right? It's not perfect, but close enough, okay? And so if we know that the vertex is negative 2, negative 27, how does that relate to this form, right? And so we've seen stuff like this before with square roots and stuff when we looked at graphs of square roots and talking about shifting, right? But that negative 2 for the axis of symmetry is right here. X minus a negative 2. And we have that minus 27 right here, okay? And this form is derived from completing the square, which we learned last week. Okay, if I were to take this and complete the square, we would get something that looks like this, right? Except you would have to divide out the 3's, okay? But let's just kind of break down this vertex form. So we have y equals a, and a is going to represent whether, kind of like how the parabola is oriented, right? So a is going to determine if my parabola opens up, right? Or opens down, right? And so if a is greater than 0, it's going to open up. And if a is less than 0, it's going to open downward, okay? What also is true is that depending on how big it is, it also determines how wide our parabola is, right? So if a is greater than 1, right, we know that it's going to be narrower, right? And let's say if the absolute value of a is between 0 and 1, right? Let's say the absolute value of a as well, because it could be negative. So if it's a fraction less than 1, it's going to be wider than the parent graph, okay? Now, the k for h and k each of these is going to represent a vertex. So if my vertex is at h comma k, then x minus h, whatever is being subtracted from x, is what the x coordinate is, and k is my y coordinate. Okay. And so another way to talk about h is what we call a shift, right? A transformation, a horizontal shift. So this determines whether my vertex is moving to the right or to the left. And the K is going to represent our vertical shift, which we'll do in purple. And when I say shift, I'm talking about in relation to our parent graph, okay? And so it's important to say it here, so I'm a little all over the place, but our parent graph is y equals x squared, okay? PH. Okay, so let's just graph a few of these, and I think you'll get the hang of it, okay? So if I look at y equals negative 2, parentheses x minus 2 squared plus 5, okay? This negative 2 is telling me that this is going to open downward, right? It's going to open down and is narrow, right? And then my vertex is going to be at h comma k, or x. So if it's x minus h, x minus 2, my vertex is at an x coordinate of positive 2, and the plus 5 is a horizontal or a vertical shift upwards, right? So we know that the vertex of this graph is going to be at 2, 5, right here. And we know it opens downward, right? And so the question is, how do we graph the rest of this graph? And so once we have the vertex, we can start to build, just find 2 or 3 points around it by making a table. And so let's see here. If I know my vertex is at 2, let's see what I get when I plug in a 1, right? 1 minus 2. 1 minus 2 is negative 1. Negative 1 squared is 1. Times negative 2 is going to give us negative 2. Negative 2 plus 5 is 3. So if I have a point at 1, 3, then I must also have a point at 3, 3, right? If I plug in 0 into x, I get 0 minus 2 is negative 2. So that's 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. So if at 0, I'm at negative 3, then at 4, I should also be at negative 3, because this graph should have symmetry, right? So the nice thing about this form is that it gives us the vertex right away. All right? So let's look at this one. My a value is 3 over 2. So that's a fraction bigger than 1. So this is actually going to be wider than the parent graph. Okay. But we know it opens upward, right? So my vertex this time is going to be at negative 4, negative 6, right? Whatever's happening with the x inside those parentheses, it's the opposite, right? So if it's x plus 4, that means I subtracted an h of negative 4, x minus negative 4. So my vertex is at negative 4, negative 6, okay? And then let's see let's find some more points, okay? So I'm going to plug in, make a table right here. Now I'm at negative 4. This is what happens if I plug in a negative 2, right? So negative 2 plus 4 is 2. 2 squared is 4. 4 times 3 over 2 is going to give us 6. 6 minus 6 is 0. That's nice. So if negative 2 is 0, that must mean negative 6 must also be 0. And I'm just going to go ahead and sketch that graph with those 3 points. Right, so bare minimum you need 3 points. Your vertex and 2 other points. Okay? But hopefully you're seeing that vertex form is going to give us the vertex without having to do with the negative b over 2a. Okay. So for your homework, you'll be graphing just a few of these on Khan Academy, right?